Good evening, ladies and gentlemen. This is Petko speaking, again, hosting from my own bedroom. Welcome all. Today we have a very special event, a very interesting event. We will be speaking about space. As usual, one of our favorite topics. Now, ladies and gentlemen, most of you are pretty much aware that space is an essential part of our future, and it will certainly be part of our children's present. If we speak about the future of communications, space travel, space exploration, doing fundamental science, and even mining other planets, it is clearly important to understand what are the main challenges that the space industry is facing these days, and what are the main issues that scientists are trying to tackle in order to make this transition possible for all of us. Now, one of the major issues that, frankly, we didn't anticipate in the beginning of our space age was the space debris or the space junk that we slowly, incrementally created around us, around our planet. Now, it is clear that for almost 14 billion years, space was pretty much pristine. And then in 1957, we launched the so-called Object 1, as is classified by NORAD. Object 1 being, of course, Sputnik, the first artificial body launched in space by human beings. Now, it was followed by almost 10,000 satellites in the upcoming years that we launched in space, and almost 2,800, as far as I checked, is the number of satellites that are currently being decommissioned or simply destroyed in space. Now, this created a lot of debris. Now, this is not even counting, all the parts that have remained from the space launches, from the rockets, from fuel tanks, and all the rest. And it is really a fundamental problem, because what we have in space right now, in the close vicinity to Earth, are objects from a size of a, let's say, a house, a regular warm water boiler, house boiler, up to like objects that are the size of a millimeter. Now, what defines them as really dangerous is actually the speed that they travel with. With a speed of almost 15,000 kilometers per hour, a small hit, even a small object, if it hits a surface, it would literally evaporate it. It will literally destroy it. And we came very close to realizing that it was actually a fact, something that happened in 2015 on 16th of July, when NORAD or the guys who were actually observing space for military purposes, they detected an object, again, the size of a small boiler, which was actually a decommissioned Soviet satellite from 1979 that came to extreme close proximity to the International Space Station. So it took, a few hours. The astronauts were commanded to evacuate into the Russian model and just stay put. Just close all the hatches, close the ISS, and just hide in the Russian model, and like literally holding their fingers together and hoping that this object is not going to hit them, because what that would have meant is the complete destruction of the International Space Station. Now, hopefully, we got lucky, and this object passed the ISS to a proximity of approximately 1.5 kilometers. So it is clear that in space right now, we have, first of all, objects that cumulatively cost billions of dollars, and they were launched in space with the assumption that it would be cheaper just to leave them there rather than try to bring them back. And now we are facing a fundamental problem of trying to navigate around this trash in order to make the third space revolution possible. So therefore, we have selected this topic for our discussion today in our month of space, and together in a collaboration with the European Space Agency, we have invited two experts to talk to us about the space debris issue that we're currently facing, and what are the possible solutions to this problem. So today we're going to hear from two of our guests. Both of them are extremely experienced in the area and specifically focused on that. And we're going to start off with Michel. Michel, welcome to the call.
Hi there.
Hi there, Michel. If you allow me, I will make a short introduction, and then I'm going to ask you to elaborate on that, if you don't mind. So, Michel van Pelt, you are the head of the cost engineering section and concurrent design team leader at the European Space Agency. You have also authored multiple books on space, the last of which is Dream Missions, Space Colonies,
Indeed.
Nuclear Spacecraft, and Other Possibilities. So can you briefly talk to us a little bit about your qualification on why is it that we should listen to you on this talk?
You
And what is
invited
it?
me.
Yes.
No, I work with the clean space people in ESTEC. I support them a lot with the financial part. As you probably know, space is quite expensive, and so it's always a whole topic. What can we afford? What can we do with the money we have? And so it's a relatively small group. I was in it from the start, basically 2012, and before very few people are aware about space debris being an issue at all. This has changed quite a bit, also thanks to you people like you making this more, let's say, public knowledge. And we're now at the stage that actually people are actually acting on it. So they're no longer ignoring the problem. Space agencies are putting some rules into effect, trying to clean it up a bit, and this is what I will go further into in my presentation.
All right. So you have prepared a presentation for us. You
Of
might
course.
just go ahead and start whenever you're ready.
All right, let's go. It should be on now. You can see it?
Yes, we can see it properly. Go ahead.
Fantastic. Okay, so I present indeed clean space in ESTEC, ESA, European Space Agency. It deals with more than space debris, also on how we build satellites, how can we maybe pollute less harmful materials, less energy, all these kind of things. But today I will really focus on the space debris issue, which is already quite a topic in itself. So as you probably are aware, we are more and more dependent on satellites. Even actually, they're so successful that you hardly notice them anymore. We every day depend on weather satellites to tell us what the weather will be, basically in the very near future, tomorrow, the next hour. We have telecom satellites, so even now probably some of these signals are going via satellite. We have the navigation systems that anytime you open a map on your telephone, you're using directly signals from space that tell you where you are and guide you where you want to go. So as we become more and more depending on satellites, we also become more and more vulnerable, of course, if anything happens to them. In fact, as Pekko just already explained, in 1957, this would be just the Earth. There would be none of this junk around it. Now, all these dots represent a satellite or a piece of debris or a rocket stage or anything like that. Of course, the size is a bit exaggerated, so it's not looking like that if you're really in space. But every dot is really one tracked object. So that means an object at least 10 centimeters or larger. So what can you see from this? First of all, space is infinite, but we don't use the infinite part of space. We use very few bits of space. You see all the satellites very close to Earth, the low Earth orbit satellites. These are close to Earth, of course, because the closer you get, the better you can observe the weather, the higher resolution your images will be. And then you have this interesting red ellipse, is actually a circle around the Earth, and these are the telecom satellites. So at that height that you see here, they are going around the Earth in 24 hours, which effectively means that the satellite will stay exactly above the same part of the Earth. So effectively, you have a gigantic telecom pole, and in fact, these are the weather and telephone, internet satellites. And you see some other bits and pieces flying around. So, but you can really see these are the hotspots, and this is also where the problems now start to occur. A little aside, there's this Heaven Above website which you can log in, set your location, and you can actually, it will alert you if bright objects coming over any time. And in fact, on a reasonably dark evening, every 5 minutes you will see a pretty sizable piece of space junk or active satellite fly over. It's quite an eye opener if you never looked at this. So how are we doing with space? So 1957, first satellite. Some satellites that have been launched, including Sputnik, have in the meantime fallen back to Earth, especially in low Earth orbit. There's always a little bit of atmosphere left that slowly slows down your satellite till it falls back into the atmosphere. This has actually cleaned up quite a bit in the very low Earth orbits, so that's been good, else the problem would have been even worse. But nevertheless, so we have some 5,500 satellites in orbit. And actually, less than half of these is actually still functioning. So that's already showing that more or less half the satellites we have in orbit are garbage. And it's even much worse than that, because also, as Petko said, very often, especially in the beginning, when you launch a satellite, you also launch typically the upper stage of your rocket with it, which stays there. And in the meantime, a lot of these old satellites have also exploded. They've broken up. They have collided with each other. And now we are in a situation where we have many more objects. So in just total amount of mass, it's almost 9 million kilograms. And unfortunately spread out all over the place. And in terms of objects, which is a bit more enlightening, I would say we have some 34,000 objects that we are actually able to track with radar from the ground. And this means that they're basically larger than 10 centimeters, which is at 8 kilometers a second orbital velocity. You don't want to be hit by anything like that. It's typically catastrophic. If it would hit the space station, very bad idea. But then when you go to the smaller sizes, we have about 900,000 objects between 1 and 10 centimeters. So golf ball size, tennis ball size, that kind of thing. Again, 8 kilometers a second, high energy involved. And then we have 128 million objects, and we estimate this because we can definitely not track any of these things, between 1 millimeter and 1 centimeter. So these are like like beans and pins and pieces of paint flecks, very small, but because of the velocity involved, still very dangerous. There's another interesting graph. Here you can basically see the number of objects in space that we are able to track. So it's not counting all these millions of little bits and pieces. These are the ones, let's say, 10 centimeters and larger. And you can really see that it's not only growing quite fast, but it's exponentially growing, and especially in the last decades. Now with this, the Starlink mega constellations, more and more satellites are launched every year, and well, it's not going the right way. Let's put it like that. You can also see that many of them are in low Earth orbit. These are the red ones, and the other ones are the geo satellites, or the telecom satellites, which are in green. Which here doesn't look too serious, but if we go to the next graph, this is the amount of mass involved, and then you suddenly see that the geo orbit is also very important, because the satellites there are typically very large. They're really thousands of kilograms. So otherwise, of course, you see the same kind of exponential increase in the amount of stuff we have in orbit. So why is this a problem? Well, first of all, even small bits and pieces have an enormous amount of energy. As I already said, it's 8 kilometers a second. If you're in really bad luck, then your satellite comes from the left with 8 kilometers a second, the piece of debris from the right, 8 kilometers a second. You have a 16 kilometer second impact. And that basically means that a 1 centimeter bolt or screw or something like that effectively hits your satellite with the force of a hand grenade. Now, if you ever seen pictures of satellites, you can imagine they're typically not designed for surviving attacks with hand grenades. So this definitely can kill a satellite. Also, the problem is that many of these small debris are, in fact, the amount of is increasing all the time, because we have, let's say, large trackable satellites and pieces of rockets that collide with each other and then break up in many more pieces. So in this case, for instance, they did a study where hypothetically you have 1,000 kilogram upper stages of rockets. They collide head on. You end up with 4,000 trackable objects. So you started out with 2. Now you have 4,000, and you have something like over 100,000 of smaller fragments that you cannot even track. So you become basically, you rapidly go from a reasonable problem to a huge problem. And collisions are just one source of why we end up with more and more smaller pieces of untrackable debris. So here you see other reasons. You see collisions. You see basically explosions from satellites when they still have propellant on board. We have also a large part unknown. So we basically know that something broke down, but we're not really sure why. And also here you can kind of see that the number is increasing. I mean, okay, it goes up and down a little bit, but the trend is definitely not going in the optimistic direction. So is this just a statistical problem that we'll have to think about now, and maybe in 10 years or 20 years it might be a problem? No, it's already a problem. So 1996 is the first documented collision of basically a satellite, an active satellite being hit by a piece of debris. This was a French satellite, which kind of ironically was hit by a French piece of rocket. And effectively, it lost stabilization because the stabilization beam boom was cut off by that. So they couldn't do much about it, but the satellite was effectively lost. This is something that could have people have done something about it. This was actually an active attack on the satellite. It was a demonstration by Chinese to show that their anti-satellite weapon would work. They launched a rocket from the Earth at one of their own satellites. It was a very effective demonstration because, in fact, the satellite was completely destroyed. And unfortunately, in a sufficiently high orbit that now we're still stuck with the aftermath. So we have now some 2,000 trackable pieces of debris because of that, and 150,000 estimated smaller pieces that we can actually not track. And the other thing is also what you see in the picture, that all this junk doesn't stay nicely in the original orbit, but because of the, they go up and down and left and right, they start to spread. So this was only 1 month after the accident or incident. It was not an accident, it was on purpose actually. And if you would look now, this red would have spread all over the globe basically. So this debris is now everywhere. In 2009, this was actually the first time it really got financially important, let's say. There was an active Iridium telecom satellite, which was destroyed by an inactive, long-dead Cosmos satellite from the Soviet Union. Very interesting, also a bit of an aside, I will not go into that, but you got also something called space lull, and this was very tricky situation here. Because basically you cannot say, okay, you come from the left, I came from the right, it's your fault. It doesn't work like that. The Cosmos was completely inactive, so nobody could steer that satellite. Soviet Union doesn't exist anymore, so you could not even blame them because the whole state doesn't exist. And actually, Iridium people could have seen this collision coming because the Cosmos satellite was being tracked. So they could have reacted on it if they had just kept track of it a bit better. So in the end, nobody paid anybody anything, but you can imagine that this could get very tricky if your hundreds of multi-billion satellite is hit by another hundred or multi-billion satellite. Another illustration, one of our own ESA Sentinel satellites, Telecom Satellites, within 34 hours after launch, it already had a collision avoidance maneuver. So this is basically avoiding what we just saw. You see, in fact, an object coming. There's an alert from the radar tracking that, hey, you're going to be hit in the next 5 hours. The only thing you can do then is move out of the way. So they had to do that, but this was the first ever time that something so close after launch had already a potential collision. That same satellite had a pretty bad career as far as the space debris concerned, but 2 years later, it was actually hit by probably something the size of a millimeter. And in fact, we have even camera photos of that. So here you see on the left, the solar array as it should look, and it was looking up till 2016. And on the right, you see this dent. And fortunately, it was only the solar array. These things are always oversized, so a little bit less energy from the solar array was not a big deal from this satellite. But you can imagine if this object hits a camera, an antenna, onboard computer, it could have been a lot worse. It can also be a lot worse if you're an astronaut getting hit by something like what Petko said. That was at least they had warning. They could get into their Soyuz if the satellite or the station was hit. They could have gone back to Earth. But if it's an untrackable small type of thing, then there's nothing you can do. You just get hit. I know astronauts say that once in a while, you know, they're asleep and suddenly they hing ping and pong, and they know there something hit the station, and they don't know what and when. And as long as it doesn't puncture a hole, there's no real problem. In this case, in 2016, also was a bad year apparently. A small impact on one of the windows of the cupola's observation window, in fact. Very tiny fleck of paint, probably, again, at 8 kilometers a second. This window was designed to keep, to stop this kind of very small pieces of debris. But you can imagine if this was been something the size of a golf ball that we can still not track, it would have gone straight through that window, and they would have had a particularly bad day. So what are we doing about it right now? Well, the first thing I already hinted at is we are tracking it. So anything at least larger than 10 centimeters is tracked. And therefore we can give this collision warnings to the space station and other satellites. And then they can move out of the way, provided, of course, they have some rocket propulsion on board. If you're just a passive satellite, there's basically nothing you can do except hope for the best, that it will just miss you rather than just hit you. So this is, for instance, on the left, you see one of the ESA radar systems dedicated for tracking space debris. But there are a lot of military installation all over the globe, and unfortunately, all these people cooperate and put all their data into one master, they call this database, so that everybody can basically benefit from this. But okay, tracking debris avoidance maneuvers is one thing. At some point, we cannot keep on going like this. So probably a lot of you have seen the movie Gravity, which is a bit over the top, of course, as it should be with a Hollywood action movie. But the problem, what happens there, like in a matter of a couple of minutes, could in fact happen in over a month or years. So effectively, you would have the scenario that a satellite hits another satellite, creates a cloud of debris. The cloud of debris hits other satellites, which then also break up and create a cloud of debris. And you have a kind of like, you know, like a nuclear explosion, a chain reaction that is basically unstoppable. And in a very short time, you basically have a whole orbit completely destroyed and polluted. Can this happen? Yes, this can definitely happen. We are not there yet. It depends a bit on how much more junk we keep on launching and not cleaning up. Worst case, in 10 years, we could be, for some orbits in this situation, best case could be taking 50 years, but we're definitely heading that way. And therefore, it's really time to do something about it. So first thing that many agencies are doing, and I'm just showing here the ESA space debris mitigation as an example. What we have already implemented for our own missions is that anything that we put in low Earth orbit, so let's say from 200 to 2000 kilometers altitude, after the satellite stops its operational life, its useful life, it has to come down, it has to be removed within 25 years. Now, if it's a very low Earth orbit, it probably comes down by itself because of the still a little bit of air resistance that you have. But then you have to actually check what is the casualty risk that something hits people on the ground. You can imagine if something the size of the space station comes falling down above Sofia, for instance, that would not be acceptable. So fortunately, now we have, over the last 10 years, let's say, made very good calculation and models on where we can predict on the chance that somebody gets hit, depending where the satellite comes down and how big it is. If you can show that it's 1 in 10 better than a 1 in 10,000 chance that somebody will get hit, you can just leave your satellites and it will come down anywhere and anytime, and you don't really have to care about it as long as it happens within 25 years. But very often satellites have big elements, like here, for instance, this large propellant tank that will actually survive re-entry. And the chance that it hits somebody is then larger than 10,000, and then you have to do controlled re-entry. So you need to put rocket propellant on board and slow your satellite down at the right moment over a special part of the specific ocean where you can safely have your satellite fall into the ocean, basically. So it is quite, it has quite some impact on the design of satellites, but we really felt as ESA we have to at least give a good example, and we will not accept our missions anymore if they pollute and create space debris. Another thing we're doing is actually, if somebody can switch now to the actual video here. We're doing some tests on better understanding of what happens if satellites basically fall through the atmosphere. So how do they burn up? How do they break up? Do they break up at all? And this then feeds back into our calculation models on predicting what satellites will survive re-entry, which ones are not, and which one are potentially a hazard for people. And this has been sped up, so it's a bit faster than usual. But you can, you can see that this particular satellite burns up, but not evenly, and you also see big pieces falling off that maybe not completely burn up and could become dangerous. All right, come back to my presentation. Thank you. So, so we're trying not to pollute anymore. We have all these rules, and part of it is also making sure then that your satellite does not become debris. So we want to have satellites deorbited. Now, some of the satellites don't need a propulsion system, so they don't have rocket engines to slow down. And then there are other ways to slow them down. So one of the things you can do is have these huge air drag sails, a kind of parachute that you deploy. That means they catch more upper atmosphere and they slow down quicker. So they will fall down quicker than normally. We also develop now materials and techniques to make sure that satellites, when they come down, they actually burn up completely. Rather than potentially hit the ground, and that will help, of course, because that means you don't need to have this active re-entry. You can basically just leave the thing in orbit and have it fall by itself without too much worries. And very important also, as we saw before, that some satellites just blow up by themselves, because when you switch them off, or they just die because the computer just stops. Many of them still have propellant on board, and of course, when the satellite's dead, the thermal control subsystem doesn't work anymore, so they can heat up and then blow up. So we are developing techniques, and they're actually now being built into new satellites, where before you switch off your satellite, you let all the propellant drain away. So at least you make sure that they cannot blow up anymore in the, let's say, 25 years that they're still in orbit. Another thing that we noticed is that batteries can cause satellites to blow up. We did some ground tests. Okay, what can happen to a battery? What happens if you overheat it? What happens if it gets hit by a small piece of debris? Is this dangerous? Yes, the verdict that you can see here in the pictures, it is pretty dangerous. The batteries do blow up, and in fact, if they blow up a big part of the satellite. So they need to be pacified. So again, that means you need to have all the energy leak out, and you have to decouple them from the solar array, so also that they cannot recharge anymore. So that will, if we follow all these rules about, not leaving debris, making sure satellites don't blow up before they come back to Earth, all this kind of thing, at least we kind of stop this, stabilize the current situation. But that still means we have all the old junk from the more than 50 years of launches before now. And these bits of pieces are still blowing up, they're colliding, so we get more and more debris. So what do we do about that? So we have found that basically, if we keep, we occasionally remove a big satellite, that will definitely limit the further increase in debris. So how do you catch a satellite? Well, first you have to send another satellite and then actually catch that satellite. So we have investigated a net system. The good thing about it is you don't have to get very close. The bad thing is it's all very dynamic. The net, every time you test it, it works slightly different. You have a cable that is kind of moving, and it's all a bit tricky, but potentially workable. Another idea that we had was a harpoon, which also works very well. It's a bit like the net. The tricky thing is, of course, you have to hit the right part of the satellite and not like the propellant tank or maybe something really hard where the harpoon just bounces off. Potentially it can work. And our preferred method is actually to do it a bit more controlled, like with a robotic arm. The good thing is, of course, it can be very gradual, very controlled. If it doesn't work the first time, you can try it again, like not with a harpoon. Once you miss, it's done, basically. The downside is you have to get extremely close to your target satellite, and then in fact you can actually hit it, and then you make a bigger problem rather than cleaning up. So the idea would be that chaser satellite goes to the dead satellite, docks with it, grabs it with the robotic arm, puts on its own rocket engines, and slows the whole thing down so the whole collection goes falls back into the atmosphere and burn up. Lots of studies we did in ESA, lots of models, theories, designs, all this kind of thing. But the last 10 years, we always lacked the money. And now, before that, okay, I forgot about my own slide, to be honest. This is a test satellite that was done in the meantime, which was testing some of these techniques. So it was not actually cleaning up any debris. It brought its own debris and then launched a net at it. In a very low Earth orbit, so if anything went wrong, then basically the thing would come down in a couple of years by itself anyway. So this kind of test helped to validate various ideas and concepts. But now this is what I wanted to go to is we actually just a couple of months ago signed a contract with a company. The company is called ClearSpace for the first ever active debris removal mission. So here the idea is that ESA is basically helping in the design and funding, so putting the money for the first mission. It should be launched in 2025, and it's gonna basically grab a piece of our own debris, ESA debris, basically an upper part of a rocket stage that went into space together with the satellite. And it's going to grab this basically. So here you see in this little graph on the left, you see we will first launch that chaser satellite. It will go to the same orbit as the object, gets very close, and it has a kind of tentacle system that can grab around the object, which also means that if the object is slightly irregular or it has something sticking out or whatever, it doesn't really matter. These arms will go around it. And then the satellite will basically put on its rocket engine and slow down, and the whole business will come down. Now, of course, it's not very efficient to have only one 100 kilogram object being removed and by a satellite that cost a couple of tens of million euro. But the idea is that this will lead to a commercial business that can, on commercial basically basis, remove debris. And hopefully not just one object, but multiple objects per mission. And Stella, who will follow me in this presentation, will go on a little bit more into this. So this is the most exciting thing happening in space debris removal at this moment. ESA Clean Space is working on all kinds of levels, as you've seen, to stop the problem or mitigate the problem, how you call this. We're having rules. We're having hopefully laws in the near future. We're having calculation models, active debris removal missions, and all kinds of exciting things. So we didn't lose hope. We think the future will be fine, but we really have to do something about it. You can follow us also on blogs. We have Twitter, we have Facebook, we have everything. So you can always follow us there. And back to you, Petko.
Right. Thank you very much, Michel. That was really enlightening. You know, it's not very often that you hear hopeful news. It's nice to hear that at least we have a plan. But as you said, you know, we're not fixing the problem with the debris that are left out there still, and this will be the more difficult issue that we need to
tackle. In fact, and well, to be honest, one of the things is, of course, the problem is that everybody says, yeah, there are solutions, but we don't know if they work. And somebody has to put the first step, you know, and then we hope with this mission to show, look, it can be done. You have no longer any excuse to say we cannot do it, because we show it can be done. And then others will follow. It was something similar with the laws that we put on ourselves about, you know, cleaning, not leaving any debris in orbit with any new mission. NASA has also similar rules. Chinese, Indian organization, all of them feel, you know, once somebody makes that first step, you kind of feel obliged to do the same.
Yes.
And that's a kind of social evolution, how you call it, but it's definitely helpful. Somebody has to make a step, and then you can show that you can actually do something about it.
Right, right. Well, obviously, the most important thing here is to make it, viable in commercial terms as well, because if you, well, it's difficult enough to convince the public to do that with public money, and you definitely need some economic stimulus there to incentivize some private to take part in this in fixing this whole issue. As a matter of fact, it seems to be the resolution to most of the problem that we're seeing today. A private with public cooperation. Here I would like now to pass the ball to Stella, who will be focusing exactly on that problem, on how do we commercialize and incentivize private entities to help us out, in dealing with this issue. So, Michel, I'm going to get back to you during our panel with the questions, where both you and Stella will have the opportunity to answer some of the questions. So for now, thank you very much. And now I would like to move to Stella. Stella, welcome to the show.
Hello.
Can you hear?
Yes, I can hear you very well. Can you hear me?
Yes. I can hear you, Stella. Now, if you allow me, again, a short introduction for you as well, a little bit more formal. You are your whole name is Stella Tkachova, just for people to know. You are a project manager for a leading Belgian space company. You have participated in the mission Sentinel-1, Sentinel-3, and a bunch of others, including Galileo, which is very familiar to our audience. And your expertise is in the commercialization of space technologies. So you're exactly the right person for the second half of this discussion of space debris. I understand you also have some things that you would like to show us, and then we can move to a discussion together with Michel. So whenever you're ready, you can go ahead and start.
Okay, thank you. So, do you see my screen?
Yes, ma'am.
Perfect. Okay, so following on Michel's presentation, I would like to talk a little bit about the challenges and the opportunities from the space debris situation. So at the moment, we are having a lot of aging satellites in geostationary orbit. In parallel, there are falling prices for satellite capacity. Also, we are observing many low-cost satellites in low Earth orbit who are aiming at cost-efficient servicing, and satellites who have commercial off-the-shelf components. In parallel, also, we're looking at satellite owners who actually want to explore and operate in an economically viable way and extend the lifetime of their satellites. There is even a European initiative called the Paris-Para initiative for a European roadmap for autonomous space robotics for commercial and orbit operations. So these are challenges, but also opportunities. So who are the stakeholders? Who are the stakeholders in this market? As you can see, there is the space agency, the satellite owners, the operators, and on the other hand, there are the insurance companies, the service providers, and so on. So these are the stakeholders at the moment in the so-called space debris market. But let's say, what is the market? So we heard from Michel earlier about on-orbit satellite servicing. We saw a demonstration for the clear space and so on. But we shouldn't forget that on-orbit satellite servicing started already a few years ago with the Hubble telescope. Actually, the Hubble telescope by itself was repaired 3 times, with the last repair, which was in 2008. So on-orbit satellite servicing, it's about debris removal, inspection, assembling, refueling, extending the lifetime of satellites. So here is a graph where I would like to show you what are actually the markets, because how important it is for satellite owners to be able to have these services, and what are the customer needs, because some of the satellite owners, they prefer actually to extend the lifetime of their satellites than launch a new satellite. So here you see a whole bunch of different markets and activities which happen, helping satellites being augmented, having their capabilities augmented, and also being refueled, and so on. Another interesting aspect, and recent studies have been taking place, are about the demand for active space debris services. So here you can see two graphs. The global demand, where you have the deorbiting, robotics, life extension, relocation. And the other one is for the geostationary ones, which is like the orbit of around 42,000 kilometers. So, of course, often there are discussions about the market demand for in-orbit satellite servicing for and extending, especially for geostationary. But this market demand is actually influenced by a number of factors: the orbit type, but also the satellite profitability. So often for satellite owners, it's extremely important to have the trade-off with extending the lifetime of their satellite and not losing their commercial customers. And also, it's important on the demand side that you have the solution which is technologically mature enough to be able to provide this service. So let me give you some examples. The most successful one, the first one, is the mission extension vehicle, which serviced the Intelsat 901. This vehicle was launched on the 9th of October in 2019, and it docked to the Intelsat satellite in February 2020. When it docked, it moved the Intelsat satellite to a graveyard orbit and started to operate it. So it actually extended its lifetime with a 5-year period by providing additional propulsion and attitude functions. This was an amazing achievement because the engineers had to design a docking system, which docking system apparently is very similar for most of the geostationary satellites. But also, this idea for this mission extension vehicle was an idea which was from quite a long time circulating, but it was very difficult to create the business model and to find actually the investors and the customers for that. And then the next vehicle is the mission extension vehicle, which was also actually launched recently in August 2020, and it's going to dock with the Intelsat 1002. So these are the most recent examples of successful in-orbit satellite servicing activities. But let's see what's coming also in the pipeline in Europe from the commercial part. Well, we have another idea. There is a European company, Italian one, called the Deorbit, which is looking at in-orbit now satellite carrier, or Cubesat Dispenser. The idea of this dispenser is actually with one launch to launch a number of little CubeSats. The other one is the German company IBOS, which is actually building modular satellites. It has the idea to have modular satellites with mechanical and electrical interface. And actually, this is a development of the German DLR agency, which was later commercialized in 2017 by the IBOS company. Basically, the idea is to have a modular space systems for debris avoidance, which will support in the long term space sustainability. And the concept is a little bit like the USB concept. pretty much, plug and play. It's the Lego concept. They're going to be having a launch on the ISS in a few months. And the idea is to be able to combine these modules just like a Lego and use them also for future interplanetary exploration. So, but let's see also beyond the European companies, there is a Japanese one called Astroscale, and they're very active in Japan in the Japanese with the Japanese Space Agency, and they are working on developing end-of-life service demonstrator. I believe they're also part of the European Space Agency program Sunrise. And basically, they're developing this vehicle which will be able to capture a satellite which has a docking plate. And it's a very innovative approach. So here are some of the concepts which are, let's say, as an example, taking place in the commercial side of the markets. But the most important is that we shouldn't forget that for satellite owners, it's very important to have the trade-off between whether to launch a satellite or whether it's much more cost effective to extend the lifetime of the satellite, particularly for geostationary satellites and especially in these economic conditions. Also, we shouldn't forget that the markets are quite nascent and they're in the initial phase of market demand. So initially, most probably, the market demand will be driven by institutions and the innovations will be financed by national space agencies. But it is very possible that by 2030, there is a demand for up to 100 satellites in geo orbit. And of course, these solutions will only succeed if there are new business models implemented and there are economies of scale. And here is a very nice, let's say, closure summary of how in the long term the Europe at least sees and looks at the future trends on exploration and in-orbit satellite servicing. Not only, it's very important to think about the standards in commercialization and the interfaces for on-orbit satellite servicing and assembly and creating commercial platforms and so on, having open source and encouraging the increased demand and actually looking at the true business cases in such a way that companies can create business. So back to you, Petko, and thank you for your attention.
Right, thank you very much, Stella, for this review. I'm really surprised by the by the commercial spirit of human beings. You know, the ideas that people can come up with to make money. You know, always surprise me. And you know, it's nice to see that there are companies out there who are thinking about you know, how they can utilize all the material that we currently have in space. Now, obviously, there are a lot of questions out there that have to be answered, and I think that the most important one is about the money. You know, that obviously we have a tremendous issue. The word "tremendous" has been really ruined by a personality in recent American politics. I'm not going to use that anymore. So we have a huge issue which will require lots of money, and obviously, as I said, it needs to be a combination between a commercial incentivization and public effort. Now, Michel, you as a representative of the European Space Agency, can you answer the question, who is going to pay for that? Because we know how ESA is funded. It's essentially, you know, public money. So who is going to pay for all of that? You know, especially in the light of you explaining how expensive that actually is.
Well, in the near term, actually, the good news is that a lot of these companies that are launching these mega constellations see also that they have a problem that they making themselves. So they have all this, you know, like Starlink, 10,000s of satellites all in very similar orbits. So they see that if they just keep on going like that, and they have another generation, at some point they're colliding with their own satellites. So these are primarily the customers that a company like ClearSpace sees. That say, look, you know, they will deorbit their satellites, but once in a while, one of those things will not work and will have to be actively removed. And there, these companies like ClearSpace will step in and basically move those dead satellites for those companies.
Mm-hmm.
So in that case, it's basically those companies that are paying for it because they see that not doing anything will be more expensive. If they don't remove their dead satellites, they run the risk that their constellation will be partly deactivated because of collisions. And then in the worst case, their whole orbit will not be unusable and you have to move all their satellites to another orbit.
Yeah,
so that's kind of the near term.
Business, yeah. Mm-hmm.
And in the longer term, one of the things, of course, we're thinking of, and this would need to be at the like United Nations level, where you have also like in the sea where the polluter has to spend money to clean up. So it would be like hypothetically, for instance, everybody who launches a satellite has to put an X amount percentage of the total value of the satellite they launch into a pot from which an organization cleans up space. That would be one of the things that could work, basically, because people are making more and more money of the use of space, and it's in everybody's interest to keep that clean enough, basically, to be able to do this kind of commercial ventures. And that would be one of the other the ideas. But we think it will be a kind of gradual approach where, like I said, people, companies like Starlink will have a direct interest in cleaning up their own debris, and then the technology will become so advanced and relatively inexpensive that you can clean up a lot more than that.
All right, well, that does actually make sense. What I'm skeptical about is, the United Nations principle that you just.
This is also one of the reasons why in ESA we put the rules on ourselves rather than waiting for some kind of global initiative. You have to. But I mean, in the end, in the long term, I think this would really work. And we have, of course, the law of the sea has very similar approach to the law of space. Let's say it's a commonly used kind of environment used by everybody on the world for shipping and fishing. And you cannot just mess it up without any consequences. And that should be something similar in space.
Yes, I mean it does seem like you don't need a carrot and a stick principle. It's as simple as the fact that if we pollute that, nobody will be able to use it, including you, Roscosmos or whoever.
Exactly. Yeah. And the other thing is the social impact. A lot of companies more and more, of course, want to show that they're nice and tolerant and all these kind of things. And it's a very bad show if you basically blow up a satellite and you just say, well, I don't really care. I'm not going to clean it up, and it will not be acceptable anymore. So
yeah, it's a bad PR, which is important in the age of Twitter.
Which is very important. Yes, more and more.
Yeah, of course, yes. All right, Stella, can you make me understand? I mean, for instance, if we take, I'm probably catching you unprepared here because I'm going to make you do some sort of a cost estimation. But let's just say that we have a 1970s Soviet satellite. How much does that cost in terms of the materials that are being that can be extracted from this satellite if it's being captured in space and brought down to be sold?
Oh, well, yes, you're right. You're capturing me very unprepared for this question, pretty much. Well, the question is, what can you use from the actual satellite? Yeah.
Right.
So assessing that, when you do scavenging of old satellites, you have to assess which parts could be used and which are not, and which are impacted by the solar flares or so it's extremely difficult question, because first, before you reach to be able to extract the satellite, you have to be able to inspect it and see what is working, what is not, and then perform any analysis. For example, when the MEF-1 mission took place with the Intelsat 901 satellite, it was one of the first satellites of Intelsat, and it was operational for a period of, and is operational of 19 years. Can you imagine, in geostationary orbit?
Yeah.
So that is why one of the markets, one of the targeted markets, is exactly inspection, and more missions and solutions from industry are targeting that type of services to provide them, to provide that assessment before they're able to give an answer to your question, pretty much.
Yeah, also the value of a satellite is in space. It doesn't make much sense, you know, to bring it back to Earth. You spend a lot of money to get the thing in space. You will spend a lot of money to get it down, because that's not easy.
Yes.
Intact. If you want to burn it up, it's no problem, and if you want to keep it in reasonable state, coming down, it will be very expensive. So you want to reuse it in space rather than do anything on it on Earth.
Yeah. Yeah, that definitely makes more sense, because it sounds, very counterintuitive that, as I said, an old 1917 satellite can cost anything, on the ground. Well, the least is, for instance, some symbolic value, or some collector's item. Yeah. But I imagine that they were not built from something so exceptional that it will be made.
It's aluminum, plastics, things like that. It's the scrap value of a car. A couple of thousand kilograms of junk. It's worth virtually nothing. Yeah. But in space is a different thing. If you have a functioning solar array, a functioning computer, which was very costly to put it there in the first place. If you can reuse it, that's another story. Yeah.
And if you can refuel the satellite or augment the
yes.
Exactly, talking about refueling and augmenting the capabilities of the satellite and putting it in the correct orbit, it's a different case. It's really, it's like what we are now witnessing. You're extending the lifetime of the satellite with 5 years, permitting to the satellite owner to continue to sell the satellite capacity for the next additional 5 years, rather than investing and having to launch a new satellite with new insurance rates and so on.
Yes.
Yeah, this modular satellite also that Stella showed is one of the examples. When you could, for instance, see that most of your satellite is still okay, but your transmitter is dead, or the payload, the part that actually makes the money is not is a bit obsolete. You could replace it with something new and better, and rather than replace the entire satellite, you replace only the bits and pieces that you are worth improving. Exactly. So there's a whole range of possibilities there.
Right. All right. Just to understand, the risks here better. Now, Michel, you did cover quite a lot of that, but let's think a little bit more about the Kessler effect, and let's speculate a little bit. So, what would actually happen if there is a big crash event? Let's imagine that the event that was about to happen in July 2015 actually happened. Put aside the human tragedy and the enormous cost and loss and everything else. You have two big objects colliding in space, the size of an ISS and a house boiler, or an average satellite. What happens with our ability to go to space then?
Well, I mean, going into space will probably still be fine, but there will be definitely orbits that become more and more risky, maybe too risky to use. And that's kind of the scenario we would be looking at. So if you would really blow up effectively the space station, that whole orbit will maybe be so polluted that you will not put a new space station in that orbit. You cannot really put it any lower, because then it will basically come back into the atmosphere in a very short time. So you would have to put it higher, which means it's more costly to launch, it's more costly to reach. You just make it more and more difficult. So this is what I also said with this low Earth orbits. You have a lot of satellites in a very low Earth orbit because they're doing, weather, imaging, things like that. You could potentially do that from a higher orbit, but then your resolution will go down, and it will be more expensive to get the satellite there. And you just make it more and more difficult. So I don't think it will be like a tipping point where you suddenly say now, space is unreachable, but it becomes more and more difficult to use it, more and more expensive, and at some point You know, we might go back to oceanic cables if the telecom satellites becoming too expensive, and it's too high insurance that you have to pay because you have a 50% chance that your satellite dies any minute. Then maybe it's less expensive to put cables down again. But we basically go back in time, no, in capabilities, which is not what we want.
Yes. How often do we have actually collisions
Ah,
like
yeah, I
that?
didn't already talk about that. Well, let's say on ESA satellites, so we have in various orbit. It's about once a year, and it used to be also like that, for instance, for the space station. Once a year, they got some kind of warning that they had to move out of the way, or as you said, that it was too late and they had to be ready for an impact.
Yes.
Now it has recently already happened this year 3 times. So this is not really statistics, of course. Maybe next year nothing can happen, but there's definitely a trend that it gets more and more often. Now, part of it is also that we are more and more able to track these things. So things that before were not visible on radar, like I said, these 10 centimeters, below 10 centimeters, you can really see. Now, the new generation of radar systems, you can see also objects down to 5 centimeters. So the good thing is, of course, that we are more aware and we can track these things, but we get also more warnings because of that. Things like 5 centimeters that used to fly by, and as long as they don't hit your satellite, nobody knows. Now you get a warning like, hey, there's a 5 centimeter object with a 80% chance of hitting you, and you'll have to do something about it. So it's kind of, you know, like, yeah, you could also say, well, I just don't want to know about it, and let's hope for the best. But it's not really not a very good idea, of course. So we will definitely get more and more collision avoidance warnings, partly because of more debris, and partly because we see it coming better than before.
Go ahead, Stella. You wanted to say something?
Yes, I just wanted to mention that I think in the long-term future, the big issue will be also about collusion avoidance between public and private satellites. Having in mind an example, the IDEA-MAIOLU CESA mission there was going to be a future collusion with the Starlink 44. And what happened is, luckily, the European satellite had very good capabilities, and the warning system worked very well. But I think in the long-term future, we will see more and more situations where commercial satellites will be in that type of collisions or will be creating that type of threat. So there will be a lot of, I think, cases which will arise. And here comes the question again, linked to space traffic management, the future space traffic management activities.
I was actually going to ask that. Obviously, you will need better coordination between the different entities, space agencies, private companies, and etc. As of today, do we have a centralized monitoring infrastructure, or is it scattered around? And if no, what are there any plans for developing such an agency, let's say, or?
Well, the tracking is pretty well organized. As I mentioned, you have several capabilities in different countries, and they all contribute to the same debris database. Mm-hmm. The business about the warning is another thing. So, like what Stella just said, when there was this Starlink almost hitting a European an ESA satellite, on ESA they were aware of the problem and they tried to get in contact with Starlink, with SpaceX effectively. And that had to go through via email. So they sent an email, and it was in the weekend, so there was nobody to read the email. I mean, this is like ridiculous, right? So that definitely is not well organized. So fortunately, the ESA satellite could move out of the way, but another time it will you know, if you have a satellite that, let's say, for instance, our satellite was not being able to move because it doesn't have any propellant on board, and you rely on somebody else to move out of the way, and you cannot reach them. That's crazy. So this definitely was an eye-opener to say, look, guys, we really have to get this organized in some kind of global space traffic control. Like you have on airplanes as well. You cannot just pick an airplane and fly through European airspace without any rules and regulations. I mean, you need to coordinate that somehow, but that's definitely at the starting point. So more and more companies initially, I think, will organize their own, let's say, tracking. So they use that database and then keep an eye on what's happening. and take care of their own satellites. But yeah, at some point you'll have to coordinate this. Yes.
Yes. What's interesting, it seems, about the space industry is that it seems like it won't require a lot of heavy regulation in terms of all these details, communication lines and coordination, because it seems like that if you don't do it, you're just out of business. You can't. It's not like a company that is freely polluting waters
Exactly.
that they're
You're polluting your own business effectively, which is
yes,
a very strong incentive. Much more
yes,
than all the other things we talked about ethics and for
exactly. Yeah.
humanity, the future, and all this kind of stuff. I mean, if your satellite gets hit, or you have to double your insurance because you're flying in a dangerous orbit, that will be probably more convincing. Yes.
Right, right.
And I would like to add here, I think the cost avoidance aspect is extremely important because with the space debris issue and problem, the incurred costs could be huge. And I can give you an example. For example, in 2012, there was the Russian Phobos gun, which actually made an uncontrolled entry in the European airspace, and the European airspace was closed for 2 hours, as a result of which it corresponded to around 20 million euro loss. Can you imagine that? So it's extremely important to address the problem, and the cost savings which we will incur will be huge benefit, not only to the satellite owners and the space agencies, but on overall.
Yeah.
So
at some point it will be too expensive not to do anything. That's the
exactly,
point. Yes.
and we are reaching that point. So
Definitely.
it's very important to act now. It's a bit late, but it's very important to address the issues and actually measure this cost savings and these benefits already.
Yeah. I think it's very interesting that this very much self-regulating and sensitive environment that we are speaking of it's definitely a positive thing, but I think that this implicit sensitivity also makes it very vulnerable to a bad actor who wants just to wreak havoc. I can imagine a North Korean missile just completely ruining our space infrastructure just because the heck of it. So this also seems to be a significant problem, and I have no idea how you tackle that.
Yeah, that's a very big point, because satellites inherently are very vulnerable. You can see it's all stuff very lightweight because it's too expensive to launch. Large solar arrays, definitely not built to be hit by anything. And as you say, fortunately, it's still quite expensive to launch anything in space. It's very technologically quite difficult. I mean, one thing is launching just anything into orbit. Another thing is just actually hitting an orbiting satellite. It's very tricky.
Yeah.
This is also why the Chinese wanted to demonstrate that they could do it. It's a bit really, an example of technical accomplishment.
Yes.
In a pretty negative way, but it definitely is not like anybody, any small country with a few dollars can kill a satellite from in orbit. So we're fortunately, there's a bit of a bridge to cross before you can actually destroy, like in a kind of terrorist attack on a satellite. Is not very close by, but it can be done, and of course it gets more and more easy, let's say, to do it, because the technology starts to be is available. The technology can be leaked, can be misused, and yes, definitely. And I know, for instance, the US, the military are really thinking about doing, making stealth satellites, or satellites with a defense system on board. Well, basically they shoot potentially at an attacking satellite. You get the kind of Star Wars situation now, which is in itself very dangerous, because if you get any kind of destruction and violence in orbit, it will definitely end up with clouds of debris. So
yes.
So it's all a bit
It
unknown.
seems like we will have to have something similar to nuclear proliferation.
Exactly. Yeah. Actually,
like
it's a very good point, because also that, I mean, it used to be only the United States and the And the Soviet Union, they have the technical capability, and now you see all kinds of crappy, sorry, I cannot say that, small countries that should not have nuclear weapons, and in fact,
Yes.
they have it. So it's probably very similar.
Yes.
Also, there, unfortunately, nobody has actually blown up anybody with a nuclear weapon. So there's also a bit of hope there, I would say.
Right. But I don't know. As you said, the technology becomes more available. Let's not speak of know-how, and all the rest. And it certainly seems that a bad actor can wreak havoc to our civilization pretty easily. At least, you did say it's difficult, but I remember. What was the name of this experiment? I remember that the U.S. tried to experiment with the launching a bunch of million needles. I don't know, Michel.
Yeah. They fortunately didn't do that. That was a long time ago, but even then they argued that it was actually a pretty bad idea.
Yes. But essentially, if you have,
you could do it. True, and it's
missile,
quite simple. I see your point. Yes. You don't need to target anything. You just, as long as you get it up there, it will be enough. That is true. Yes.
Sounds horrifying. Very cool. Speaking of like weapons and stuff like that, and looking at alternative ways to get rid of satellites. Now, with that, Stella, you did show some of the mechanisms that this can be done. Are there any like more, let's say, sexy ways to do that? Are there any magnets or lasers involved? Are you aware of some experimental technologies like that?
Well, actually, just recently I saw, just 2 days ago, actually a day ago, a presentation for having a deorbiting kit using Cubesat satellites and having a tether. Another other sexy concept was the grapple handle of Untethered Limited. So they're looking at a handle kind to grab of the space debris. So the problem with satellites and in-orbit satellite servicing and space debris removal activities is that the satellites were never built to be repaired or serviced. And that is now, it's starting to change. Starting to change the model of thinking. There have always been built for one single use, and there was never thought that they could be repaired or refueled and so on. So that is the major challenge at the moment. How to repair, one of the major challenges is how to repair our satellite, which was built for one-way use in a geostationary orbit or in LEO, and how to find the funding. And because, as we started in the beginning of the discussion, who is going to pay for it? Who is going to finance these innovations? Who is going to take the risk?
Yeah. And as Michel, clearly answered, it was quite an enlightening answer. If you want to participate in that industry, you have to help to clean it up. So it sounds like a way to do that. I'm thinking also of like when they're building new satellites. Is there any armor being considered? I'm sorry about the infantile question, but
no, it's actually a very good question. Short answer is basically in typical satellites, no, because it's just you do the risk versus consequences of putting armor on the satellites. Typically, you don't want to have anything blocking, because a lot of satellites, you have antennas, cameras, things like that. You don't want to have anything in the way. And it's always about mass. If you get too heavy, you have to go to the next more expensive rocket to launch it. But for instance, on the space station, they do have shielding, in fact, because of course there are human lives involved. It's a different kind of balance. And they have, in fact, shielding, yes. But you cannot shield everything, of course. I mean, we saw this impact in the window. That window, I think, has 5 layers. So it will take a while before something goes through all the 5 layers. So that's one of the things that you think about shielding or kind of armor, basically. But it's all a limit. I mean, if something the size of 10 centimeters hits even that debris shield on the space station, will definitely go straight through. You cannot have an armored tank in orbit effectively. No.
Yes. Unfortunately.
They also, I think it's important to mention that from 1999 to 2015, the space station made more than 23 maneuvers to avoid space debris. Can you imagine?
It's a big station to move.
Yeah, it's a big. The space station is the size of 2 football fields. So you can imagine,
It's not literally parallel parking here. Yeah, it's
exactly. And at the moment, they also have on the space station, they have space debris sensors, which are actually permitting to identify the smaller parts of the debris. But it's a really serious problem. And I think in the long term, it will be also a problem for future commercial space stations, which will come. There will be even a bigger problem for them, because now the ISS is financed by the ISS partners, NASA, ESA, and so on. But in the future, it will be big trade-offs for commercial space stations, I think.
Mm-hmm.
Yeah. I have a question about these cube satellites. Now, Michel, you showed a video of one of those that you were burning.
You're burning up, yeah.
Yeah. Now, cube satellites, I see them a little bit as drones here on Earth. They're very prolific, very cheap to be made. They change, the way we do things. But at the same time, it seems at least that in most countries we have lack of regulation of this type of technology. Can we say the same thing about space now? Now we have, of course, Starlink, which is a big project and all of that, but essentially, pretty small companies can participate in that business. Including, we have one Bulgarian company, for instance, that is very good in launching these. So, how is the regulation going in terms of these cube microsatellites?
Well, there's no global agreed regulation. So it's again on the level of each individual space agency. So for instance, also ESA participates in Cubesat projects. And then we put the regulation, in fact, that the thing has not should not become a piece of debris. So it will have to come down in 25 years. Fortunately, with CubeSats, very often they anyway want to go in a very low Earth orbit because they have limited amount of power. So the closest you are to Earth, the easier it is to communicate, the more effective your camera is, all these kind of things. So the problem, to be honest, with CubeSat has not been all that bad, because they typically, if you leave them up in a couple of years, they will come down by themselves anyway. So this might, of course, change when these things again also become more capable, and then we have indeed the mega constellations, which are not really CubeSat, they're a bit bigger, and they're in much higher orbits, and there the problem is indeed present. But for CubeSats, at the moment we're not too worried about that.
Right. Okay. When we're speaking about these cube satellites, we know that there will be tens of thousands of these soon in space used for communication. I was just wondering, speaking of because radio communication is still the primary way that we actually communicate with space and foreign civilizations, hopefully. But do the space debris actually have an impact on our communication from Earth and to Earth in any way?
No, not that I'm aware of. I mean, even any beam of a high gain antenna is still pretty wide, and if anything flies through it, 8 kilometers a second, it's less than the blink of an eye. So I would not really expect. It's not like we have a shield of debris that is blocking signals. So by then we are basically really in trouble. If it gets that bad, then before then we already have run into other problems that will make it impossible, in fact, to launch a satellite anymore. So
yes.
So it's not we're not there yet, fortunately.
Right. Yeah. Very good. Okay. I want to get into some specific projects that ESA is currently facilitating or doing. Can you talk a little bit about the mission Adrios? That is specifically meant to be dealing with space debris.
Yeah. In fact, Adrios has a bit confusion. This is actually the Clear Space 1 mission that I presented. So it's a typical government business. In ESA, we have an initiative called Adrios, which is the program or the project. And part of Adrios, we have basically the contract with Clear Space, which is building the Clear Space 1 satellite. So in the end, it's the same thing.
Right. Oh, okay.
But that was basically, we had to give it a name before we had selected the company, because there was competition. There were other companies offering similar solutions, and of course, we had to do the trade-off. Okay, what's the least risky, the most commercially viable, the most cost efficient, and then we ended up with Clear Space 1. So,
Right.
but effectively, it's the same project. Yeah, it's not that we have multiple space debris mitigation missions going on. Unfortunately, we don't really have the money for that.
Yes, I can imagine. I can imagine also that because we have a question here from the audience that other space agencies also have an equivalent of that as far as is that the case with Roscosmos?
There's several companies, also agencies working on it, and of course you have a lot of like similarity. Like what Stella showed in these U.S. missions that are going to an old satellite, dock with it, and basically extend its life. It's very similar to what we are doing. It's not really removing the satellite, but the technology involved is very similar. You have to get very close. You have to dock. You take over propulsion from the old satellite. It's very similar. So you can imagine if you can do that, you can also deorbit a satellite. So the technology is being developed all over the world. But I would say the ESA Clear Space 1 Adrios mission is the first one that is really going to remove an also imported inactive piece of debris. Because of course, it's one thing to dock to an active, nicely stabilized satellite. It's another thing to grab something that is stumbling and might have deformed in time over 20 years in space, for instance. So it's not exactly the same thing, but I definitely would say that a lot of space agencies and companies in the world would have the capability to do it, yes.
Actually, I would just complementary to what Michel is saying, I would just say that the Japanese, JAXA, the Japanese Space Agency, they're very active in having a space debris commercialization program there. So they're actually working on how to commercialize that type of services, encouraging the industry to be participating.
Well, the more the better, of course. This is
Of
not
course,
the ESA
yes.
mission is not the idea.
No,
We want
no,
to be
it's
fantastic and be the first one. We want rather to be
competition,
have
competitive
20 other
environment.
people exactly. Yes, because the idea is to get rid of the problem, not to have one nice mission with an ESA flag and then say, okay, done off our action list and let's move on to something else.
No, it's
That's
the
not the
idea
point.
to encourage the industry to
Exactly.
develop solutions and to which will have commercial customers in the end. That is
and
the
competition
idea.
is always the best driver for this kind
Exactly,
of commercial situation. So again, the more the better. So definitely.
That's very interesting. But I need to take a step back because we have a very specific question here in terms of the maneuvering of machines. Now, Stella, you did say that the ISS had to do some maneuvers 23 times. Did you say
correct?
in the last?
Yeah.
Yes, which is totally absurd. But as far as I understand, the ISS has some sort of safety zone. Is that correct? That is determined to be really dangerous. Do we know what this safety zone is? How much kilometers is it?
I don't know it by heart actually. It's a couple of kilometers, and it also depends on the direction. I think, Stella. Correct?
Yeah, I think so. Yeah, because for example, when they were doing the ATV docking to the ISS, they had the astronaut inside the International Space Station. He was maneuvering it, and when it couldn't dock, he would press the ATV would go back. So there were several times. So I think it was a few kilometers, at least 10, I think, if not more.
You basically have to show that you're in full control before you can get any closer to dock to the space station. You don't want to accidentally slam into it.
Because they also had, I remember, some issues, but not with the ATV. I think it was with a Proton, with some of the sensors not working, and then it went back because of that problem.
But space debris doesn't care about these zones. I mean, it will just fly through.
Exactly. So. Yeah.
But I would imagine that this is also true for satellites, right? I mean, you sort of estimate what are the odds of it hitting or getting as
actually, when we predict a collision, it's always with hundreds of or sometimes even kilometers of uncertainty. It depends a bit if the object has been very well tracked by radar and also recently because the orbits slowly change over time. Yeah. So if it's something that has just been found 5 years ago and has been tracked once by radar, and then you could be kilometers off by your, but you don't know. I mean, it's a bit, Worst case, you basically you move in the wrong direction. You do the avoidance maneuver and that actually increases your risk because you're moving in the wrong direction. So it is very tricky, and very often the warning, and now as we saw with Starlink and Aeolus, and also with the space station lately, was sometimes really short. In a matter of hours you get a warning. So it's not that you have a couple of weeks to figure everything out and do we have to move or not and all this kind of thing. You have to react pretty fast. And typically, and then this definitely has to be improved by more radar system, better tracking, and more coordination, I would say. Yeah.
And I think comparing in the way the International Space Station with satellites, it's not maybe it's like comparing apples and pears, completely incomparable, because the International Space Station is a space laboratory costing more than 100 billions, but mainly with human lives on board.
That's the big difference, of course.
And endangering them and being able to react is really, I mean, very important. And I think, as I mentioned earlier, for future commercial space stations, it will be a huge challenge, that type of debris issue and debris problem. And at the moment also for the ISS, it is, and it's a major concern. So we shouldn't be negligible at all, because it might be possible that in 10 or 15 years or 20 we're not able to do any space exploration or go even, because of the whole debris, human space exploration. That's what I mean. We might end up closing all the programs for human spaceflight just because we have polluted the orbit so much that we are not able to safely send astronauts on board the space station or any other station. And this is, therefore, it's very important to take it also from that point of view, that it's a threat to human safety.
Yes, and I can imagine this will also be a showstopper for the expected from all new industry of space tourism. Although I imagine that space tourism will be taking much lower orbits, right?
Yeah, that's suborbital, so it's not the same.
If it is suborbital, yeah. But we had a couple of these participants, participants on the space station. They run the same risk as professional astronauts, and But Pascal, I mean, you're right that just now at the moment where we start to really want to expand in capabilities and use of space is exactly when we run into, well, a kind of wall of space debris if you don't watch out. So yes, that is a bit of a thing.
Right. So what is your general view on space tourism, by the way? Because when we're speaking about space junk here, and we usually relate junk with the amounts of people that we have at a certain location. So how do you view that? Do you support that?
It's a very different topic, of course. I mean, on the space station, there have been indeed people that are, well, not really ordinary tourists. I mean, you need to have at least something like 25 million to pay for your ticket and need to be healthy and all these kind of things. So, and suborbital, actually, it has hardly any impact on space. So it would be more like, a tourist flight. Of course, then there's all kind of things with pollution and everything like that. But that basically is a different problem than space debris. I don't think we have in the near future a problem that will be like, like mass tourism with people messing up orbits and throwing garbage out of the windows or things like that. It's anyway very difficult to do in a spacecraft. So I don't think we're there yet, fortunately. But who knows? Maybe in 100 years we'll have pollution of the moon and people leaving footprints everywhere that never disappear. And actually, there are people worried about it, especially in the US. They want to have now this law about having a safety zone, for instance, around the Apollo landing sites. Because indeed, if somebody will just put his big foot on top of Neil Armstrong's first footstep, it's damaged forever, no? And it will stay for millions of years. So that's another kind of pollution.
I never even thought about that. That is.
Yeah, people did think about it already, so they're worried. Yes, it's not yet a problem, but.
Oh my God! Having a walk on the moon will actually have your steps there for millions of years.
Yeah, Yeah, it doesn't disappear. And actually, when there was this Google Lunar X Prize, remember there was this idea that everybody could, or there was a race for people to land a rover on the moon, and one of the prizes, bonus money you could win, is making a nice picture of, for instance, Apollo 11 landing site. And there was, of course, like what happens if some uncontrolled rover just drives straight through that site? I mean, that's a bit of a thing. So this never happened because of basically, well, it was too difficult, too expensive, and all this kind of thing. But you know, it's something that like 30 years ago nobody would have thought about. Basically, like space debris, it was not really an issue. You could never really dream up that someday we would launch so much stuff. It would get so easy to get into space that you would actually pollute it. It's the same with
Yeah.
the moon. I mean, there's nobody's worried about it now, but who knows in 100 years?
Yeah. I would never underestimate our ability to screw things
To
up.
Yeah, exactly. Yeah, that's what we can learn indeed. But at
Yeah.
least we're now aware. I mean, 50 years ago, you could say nobody could have foreseen this.
Yeah.
Although we found some old articles from the 1960s where people already were putting an alarm on, let's say, well, if you continue like this, we'll end up with space debris problem. There were actually people thinking about it at the time. But okay, now we cannot. I mean, we have learned from history. We know that everywhere we go, we potentially mess it up, and
Yeah.
let's learn from it at least. But let's be ahead this time rather than having to clean it up afterwards. Yeah.
Right. I mean, okay. All right. Well, guys, I want to thank you very much for your time and effort here. It was very interesting and very informative. I'm grateful for the work that you guys are doing. I mean, I think we are in this sort of together. You're doing it in a more professional manner. But I think it's important for people to understand, how significant this problem is. Just just to be better citizens and to push all the levers that they can in order to influence public politics in a way to to make it possible to solve that and at least make science at least more popular and put it and return its place where it's supposed to be in the public consciousness. So thank you very much for the work that you've been doing. I wish you a lot of professional success. I mean, God knows we need it. Not to put pressure on you, but
we're used to it. Don't worry.
Yeah, for the sake of all of us, try to stay focused and mobilized, so we can all have a better future together. So thank you very much for participating here tonight, guys. Thank you.
Thank you.
Well, thank you as well. This was
All right.
really nice, actually.
Yeah,
Very,
thank
very
you.
good. Very good. Very good. I hope we'll have the opportunity to have at least one more event with you, or multiple events. So thanks again. I wish you good night. Now I'm going to say a few words back to our audience, and yeah, I wish you all the best.
Thank you. Bye.
All right. Before we go, of course, I would like to thank the European Space Agency for giving us the opportunity to get in touch and collaborate with people like Stella and Michel. I want to thank all of you viewers again for being today with us. I think we have a couple of slides now to share. As I said, it is our month of that is devoted to space. So some people are doing Sober October. We are doing Space October. So here we go. So we have a few more events coming in. Of course, you can have a look at our Ratio calendar on our website and follow our events that are upcoming. And of course, other organizations are doing also public events popularizing science and space topics. Of course, on the 20th, we have our next edition of Ratio Online. We're going to speak about the telescopes of the future, the world's toughest material, and something about eagles. So stay tuned and see that. Now, of course, comets is the other important topic that we're going to cover on the 27th, again at 8 o'clock. We're going to speak about the Jetsons and flying cars and about the planet called Pi. So again, just remember each Tuesday at 8 o'clock, we're, trying to do this. So I hope you do enjoy that. Again, you can check our the videos and of the events that we've done during 2019. It seems like a different era. You can see our stage events that we did during our space month. So have a look at those as well, and really enjoy them. Of course, we would like to thank all the people that are supporting us, our how do you call that, patrons. So if you guys also want to help us in our mission to popularize science and talk about science, um, and trying to make the world a better place in the best way that we see it, you can always support us on patreon.com slash ratio bg. It's difficult to do these in English. Again, go to our website. You can see all the stuff that we are doing: podcasts, video, events, our store, and our newsletter. I think that was all from me today. So please stay healthy, be careful, work out, read a lot of science, read a couple of novels a day. Take care of your kids and take care of yourself. That's it.